talk about a practical introduction to telemetry tracing. I need to watch where I'm heading. I'm Nicolas Fränkel. That is my second Devnexus. The previous time was before COVID, so probably you don't remember me, or you don't know me at all. I'm a developer. I started a bit before 2001, so I am quite, let's say, not old, but experienced in the industry. I worked always on projects and in several different roles: developer, team lead, architect, solution architect. And then I became dissatisfied with projects, customers, requirements, politics, and stuff. So now I'm doing developer advocacy. So whatever I say here, if you don't listen to me, I won't take it personally. That's up to you. Right, thanks a lot. So in the good old days, we did monitoring. And monitoring was actually having a bunch of people seated in front of a big screen wall and looking for anomalies, looking at everything run as expected. More than 15 years ago, I visited one big production site in southern France, where actually they had what they claimed was the biggest screen wall in France. It was really big, probably that big. So yeah, today it's funny, but at the time it was really good. And so we counted on people to do alerting. There were no real alerts. And then the system became distributed. And of course, with a single monolith, it's hard to do that, it's not fun, but when it becomes distributed, it's not possible anymore. Note that I'm talking about distributed systems. I will try to avoid the word microservices, because I think it's very tainted. Some people think it's a very good thing. I think it's a mostly useless or bad thing in most contexts. Sometimes it's good. So I will talk about distributed system because everybody is doing distributed system. Even if you are not doing microservices, you are doing distributed system. Even if you have an app and a reverse proxy and a database, it's distributed. Right? And so we wanted to have something which was beyond monitoring. And so then came the idea of observability, this concept. This is the definition from Wikipedia. I leave up to you to read it. It's a pretty good one. So basically, in a sense, you've got the three pillars of observability. Does anybody here know about the three pillars? Okay, just so we are on the same page. Who here is a dev? Great. Who here is an ops? Nobody. Well, one in the back. Yeah. And who here is a DevOps, whatever that means? Couple of hands. Okay, this is good. This talk is actually for developers who want to help their ops colleague, or for DevOps who want to help themselves, or for ops people to show, hey, devs do this. So, three pillars of observability: metrics, logging, and traces. My talk is focused on tracing, but still I have a couple of slides to describe the rest. So metrics, we have been doing metrics since ages. The screen wall I talked about, basically they were watching the CPU, they were watching the RAM, they were watching the issues, whatever. We have been doing that for ages. I believe, perhaps wrongly, but I believe this is a solved problem. Next problem in this space would be to go from very low-level metrics, such as physical resources, to high-level metrics, like number of business transactions, whatever. But this is the same idea. You just need to build those high-level metrics yourself. Logging is surprisingly it's not that solved, in my opinion. At least that's what I observed. The first question you need to ask yourself is what to log. Do you automatically log stuff, or do you log manually? It's very tempting to think, oh, I will automate everything. And it's very tempting, so I did it in the past, saying, oh, I will use some like user agents, aspect-oriented programming to log, when you enter a method, you log the parameters. When you exit a method, you log the return value, and oh, my life will be so much easier. Not really, because perhaps you logged password or stuff you didn't want to log. So low-hanging fruit, not that a great idea. The logging formats, we have been taught for a long time we need to have human-readable logs. That works when you have a single server. When you have many, many servers, probably you want to do distributed tracing, distributed logging. So, sorry, again, centralized logging. And then you want to aggregate them, and then you want to automate it. And in order to automate aggregation, you need to have a machine-readable format. So my suggestion is probably, instead of having human-readable logs nowadays, you should have machine-readables. So you should write the logs directly in JSON. So you don't need an additional transformation step, like with, I don't know, Logstash, to read, to grok the pattern, to put it in JSON, and then to send it. Also, funny stuff. When I started to write Java, I was told, you shouldn't write to the console. It's very bad. Very bad. You should always write to files, right? And nowadays, where do the containers are logging? The console. So depending on your context, you might also need to evaluate that. And as I mentioned, you need to do centralized logging at some point. You will probably need to do it. So now that we have more basic understanding, two ways to get the log. First, the system itself, the app itself sends a log, or there is a third-party system that scraps your logs. There are pros and cons in both sides. You need to understand them and to decide. As I mentioned, you need to parse the log. If you wrote them in human-readable format, probably you don't want to do that. Write them directly in JSON, but otherwise, Logstash or whatever. I'm more familiar with the the ELK stack than others, but probably depending on your stack, they are the same tools. Now you need to think about storing the log, how long, how much will it cost. You need to think about, of course, searching the log, which is the most important stuff that you want to do. Like, hey, I have this issue, where is it in the log? And finally, in which UI you want to display the log. Here, couple of very famous, very widespread logging system. Perhaps you are using them, perhaps not. Just have a look. Third pillar of observability is tracing. I love Wikipedia definitions. I think this one is not the best one. So I have come up with my own definition. Yeah, I never read my slides, so I leave up to you to read it. It's useless otherwise. Slides are for me to remember what I want to tell you, or in that case, for you to read, but otherwise, useless. So tracing, as I mentioned, and distributed tracing is not, for me, really a solved issue. Hasn't been a solved issue for a long time. I think we are coming to terms about it. But basically, there were three pioneers in this area. Zipkin, who knows about Zipkin? Pretty popular in the Spring ecosystem. Jaeger, great, and open tracing as well. Open tracing, you can forget about it because it has been merged. I will talk about it later. So how do we do tracing? I will only focus on how to trace HTTP requests. It's already a lot of issues. And basically, fortunately, there is a spec for that. And the spec is aptly named the trace context specification. And basically, it's quite easy to understand. You have two concepts. The trace one, which basically you can think as a business transaction or a HTTP call that spans multiple components. And the span, which is this business call inside a single component. So for those of you who have a more graphical understanding, which is my case here, now I need up, yay, it works. Here, I will make a call, so I will go through different components, X, Y, Z, and I have a single trace, because it's a single business transaction, but then during this time, I will have several things happening in each component. So the idea is here, X is the first component it goes through, so it has no parent ID, and then it will call Y and Z, and both will reference X as their parent ID. And so each component will send data to somewhere, and then this somewhere will assemble it in a graphical way. And that's where OpenTelemetry comes in. Who has never heard of OpenTelemetry? Okay, great. You are in the right room. So basically, OpenTelemetry is a collection of tools, APIs, and SDKs that allow your application to send traces somewhere. What happens afterwards is not OpenTelemetry problem. The idea is it should work across multiple stacks so that you can have a Java app, a Python app, a Rust app, a Go app, a Node.js app. They will all send their traces somewhere, and then you can trace the business transaction and see what happens. It's an implementation of the trace context specification, which is very cool. As I mentioned, you can forget about open tracing because open census and open tracing merge together to create OpenTelemetry, and I mean, it's rare enough that two projects merge in a friendly way, to be noted. It's a CNCF project. It's Apache v2 license, and it has already a lot of followers on GitHub. And to be honest, I see a lot of traction toward it, so that nowadays it can be considered a de facto standard. Everything, does it still work? Yeah, everything again, here is microservice, but think about a distributed system. Whatever will send the traces to what is called an OpenTelemetry collector. So OpenTelemetry cares about the format, cares about the protocol, cares about this stuff, and what happens afterwards, as I mentioned, is outside its scope. Which is still good, because it means that the previous tools, for example, Zipkin or Jaeger, can implement the protocol, can implement the format, and keep their storage, their UI, whatever they want. And that's the case. So basically, those two components that are still in usage, they provide compatible OpenTelemetry interfaces. So now, as I mentioned, it's for developers. How would you do it? There are basically two ways to do it. Either your stack has a runtime. Java has a runtime, it's a JVM. Python has a runtime. Rust doesn't have a runtime, it compiles directly to binary. So if you are in the case where there is a runtime, you could auto-instrument, like I did before with my logs. In the logs, that was not that a great idea. For tracing, it's a very good idea. If you want to go beyond, you want more details, you want more precision, you want to tweak the auto-instrumentation, or your stack doesn't have a runtime, you need to manually instrument your code. I believe that auto-instrumentation, if you start with OpenTelemetry, is a super nice low-hanging fruit. Effort is very low and benefits are readily available. Moreover, you don't couple your code to OpenTelemetry, meaning that your developers, they don't need to know that their application will be instrumented. And that is very, very nice, because I don't know how you are organized, but basically you can have your developers continuing doing their stuff, being oblivious of OpenTelemetry, and then DevOps, or I don't know, like creating the containers and adding the auto-instrumentation in the container. I wanted a demo, so here is a very stupid demo. I have a user and they want to have product data. So I've been working in e-commerce. I love how easy is it for people to understand e-commerce. So first, I will have an API gateway, which will forward the stuff to a Spring application. And I don't know why I don't have my icons, but this is a Spring Kotlin application. And then it will return basic product data, products that are in the catalog, and it will ask for 2 additional pieces of data, the pricing of each product and the stock of each product. So this is a Spring Boot Kotlin application, this is a Python application, and this is a Rust application. I believe here you are mostly Java developers. Here, who is a Java developer or a Kotlin developer, a JVM developer, let's say? Not that many. Python? Rust? Nah. Yeah, I wanted to be the cool kid, but if it doesn't talk to anybody, that's fine. Actually, that's where I had the most issues, like working on OpenTelemetry. Anyway. So as I mentioned, the entry point is the most important point because it's the one that generates the parent ID. And either you have a reverse proxy or an API gateway. Here I'm using an API, I'm providing an API. So basically, I have an API gateway. And I have the Apache API 6 API gateway because I work on the Apache API 6 API gateway. And just for your understanding, who knows about Apache API 6, by the way? Great. I'm happy to have come here, so perhaps you will know about it afterwards. Who knows about Nginx? Good. So Apache API 6 is built on Nginx. The problem of Nginx is that it was built at a time where downtime was not an issue. So every time you need to change the configuration of Nginx, you need to switch it off and on again. So the idea is afterwards, they decided, OK, we will create a project called OpenResty, which is a Lua layer that allows to change the configuration of Nginx like in real time without switching it down. But then it's not that comfortable to use, so Apache API 6 is a layer on top of that that provides out-of-the-box plugins to do regular stuff like, I don't know, you want to redirect, you want to proxy rewrite, you want to split the traffic, regular API gateway stuff. OK, that being said, this is how you configure it, and now I will switch to the demo. So I had an issue starting the demo, so it's already started, fortunately. Yes. It's probably too small, right? Is it better? Great. So I showed you the architecture. I've implemented the architecture on Docker Compose. I have some issue. Probably I will switch it to Kubernetes at some point, but right now it will be good enough. So I have the Jaeger image. Here, I'm not using every single component of Jaeger in different containers. I'm using the image that has all, because I'm not a Jaeger specialist, and it works like this. So it's good enough for me. I just need to configure it to say, OK, I want to communicate with Jaeger using OpenTelemetry. Then I have Apache API 6 that used the latest and greatest. It depends on the catalog. So I first want the catalogs to start. Catalog is my Spring Boot Kotlin application. Here I have like a couple of non-relevant configuration. I will tell you about it afterwards. That is the most important one. I go to the stocks, I go to the pricing. Here I have all the hotel, regular, standard stuff. Because this talk is only for tracing, I actually removed the metrics and the logs, but it could be easy to do it. Then I have the pricing, you can see it's the same, and I have the stock, it's the same. On the Apache API 6 side, I actually say that I have a plugin called OpenTelemetry, so I need to activate the plugin, and I can configure it. So both, it will be known in OpenTelemetry as API 6. I can send it the address, so 4318, and then I configure the routes. That is not that important right now. Just understand that I need to forward some stuff to the different upstreams. Great. Now I have my Java application. And as I mentioned, it's a Kotlin application because I love Kotlin. Oh, perhaps the POM is the most important. 301, so nearly at the latest. I think it's 302 at the moment. I'm using Java 17, which is not bad. Kotlin nearly the latest version. I'm using R2DBC because it's a reactive application, right? Everybody loves reactive, so it's a demo. I can do whatever I want, even if it's not warranted. Webflux and all the Kotlin stuff. Here, for the moment, I will pretend I don't have this dependency. I'm very worried about, like, I have two versions. I have the auto instrumentation and the non-auto instrumentation. So I will switch my code to the non-auto instrumentation first, but I keep on the Docker Compose side the auto, the full-fledged, because I'm afraid if I stop it, it won't start again. So the demos god are today not with me. So I'm very careful about that. Regular stuff. And on the Java side, you can see I have nothing, because I don't have the dependency at the moment. I have nothing that is hotel specific. As I mentioned, I will start with auto instrumentation. Good. And now the Docker file, which is the most interesting one. I'm using like two steps, multi-stage build. First, I compile, I build, and then I have a GRE to run it. And on the second stage, you can interrupt me at any moment, right? Is it good so far? Great. On the second stage, I add the OpenTelemetry 22.1, and I run it as a Java agent. So as I mentioned, your developers, they don't need to know anything about OpenTelemetry. They don't even need to know that they will be auto-instrumented afterwards. The person who does the Docker build file, of course, requires it to do it. And now, what I can do is I will curl. So I will curl localhost 9080 / products. I hope it's products. And I can do something a bit smarter even. I can pass, because I've configured here API 6 in such a way that it actually like traces additional data. So the root ID and the HTTP, the request method, those are Nginx variables. This one is one I can pass here. So I can pass an additional header, and this header is called, so H, is called x-hotel key, and I say, hello, Devnexus. And now the fun part is the first call will be super, super long. Yes. So I have my data, which is not that important. If I do the call the second time, it will be much faster because the JVM has like woken up. And then I can check the result. So I will do localhost. And here I also go through the API gateway. So everything is protected through the API gateway. I can try to find the traces, and on Apache API 6 I find my two calls. So already you can see the first call was 6-something seconds. Second call was less than a second. Caching, JVM, whatever, it's much faster. And now I can see everything here. So as I mentioned, this is actually, yes, here. This is the business transaction. So this is one single trace. And here, horizontally, I have all the spans. And we can get details. So you have like out-of-the-box details, and you have details that you've configured yourself or that can be configured. So here, big enough or not? So here I have my hello Devnexus with my hotel key. Here I have the request methods, I have my route ID, I have like several metadata that I can trace. Need to get back here, then I go into the catalog. I have a warning that I didn't see before. Interesting. So I have clock clue because it's a distributed system, so it's not sure that every clock of every system is at the right place. Again, couple of tags, whatever. And this is important. So here I also have manual instrumentation, but just forget about it for this moment. Without doing anything, I already have this one, this method. And because it's Kotlin, it doesn't look that nice because it's generated code. I have this method, and normally I think it's all. Also, what's interesting is, I don't know if you noticed it, but in my Java code, I used coroutines. So basically, normally, I should be using coroutines to get, for one product, both the price and the stock. I'm not a coroutine expert, but it seems that I am doing the correct stuff, because here, sorry, I don't see it here. I will take the other one, which is smaller and easier to read. Yes, this is easier to read for me. Here, I'm doing the prices and the stock at the same time. So here I have the stock, here I have the pricing. So I know that they are parallel. So you can also, with distributed tracing, understand stuff about the code itself. You can check for like bugs. Something interesting also, I asked for every product. I am doing a stupid for loop, so I could be smarter. But here you can see that I'm doing like sequentials for I have 3 products, and it goes sequentially through every one of them. Stupid, but good. At least I can understand my system. And finally, here, the catalog gets directly the stock, while it goes through the API gateway to get the pricing. It's not important why I wanted to do that. It could be I always want to do some authentication on the API gateway, or I don't care, or whatever. But then you have the 2 examples. Again, you get more insight into your system. Stuff that you wouldn't have known just by looking at the architecture diagram like this. This is not something that you can understand. Here, with distributed tracing, with open telemetry, you exactly know what happens. I have a bit of time, shall I check the Python codes? Would somebody be interested? Raise your hand. If you don't raise your hand, I won't do it. Nobody is interested in Python? Okay, that's fine. Could you please repeat a bit louder because I'm quite old? Yes, so the trace ID is actually, you don't need to care about it. It's basically just the way to reconcile between the different spans. So perhaps it's displayed. I think it's, yeah, actually it's displayed. The trace ID is here. So every one of them has a different trace ID. The span ID, the thing, hey, that's my like parent span or whatever, it's not important. What is important is this. It's just like a primary key, a random UID. You don't care that much. Okay, so no Python code. That's fine. Yes? No. So the question is, did I have to annotate the methods I wanted to instrument? And the answer is no. I don't need to. Here I'm using auto instrumentation. Again, the trace is a bit different because I don't want to restart because I'm a bit afraid it won't start again. But basically, this is the code. I did do nothing. Even better, I have no dependency on OpenTelemetry at all. The magic happens only in the Docker file through the Java agent. So it's not at development time, but at build time that I'm adding the OpenTelemetry feature. And that is very important. As I mentioned, auto-instrumentation means it's a low-hanging fruit. You developers don't need to know about OpenTelemetry. Just the person who does the Docker file or whatever you are using needs to understand about it. Yes? So the question is there a small amount of time that it slows down the build? And yes, of course, because you need to download it. Here, during the build, I'm downloading the agent from the internet. Of course, you could have like reverse proxy with caches. You can have an internal registry. I mean, there are ways to optimize that, but by default, yes, of course. And I'm always, I can already have a hint of the next question. Is OpenTelemetry slowing down your application? And of course, everything that you put in your application slows down your application. By how much? I don't know. You need to do the thing yourself. But think about it. Is it better to go fast without knowing where you go, or to go a bit slower with the clear windshield? It's up to you to decide. I know my answer. Yeah, you had a question. Yeah. Experience, yes.
I'm not sure if you already talked about this, but typically when setting up tracing, set like a percentage of how many
yes.
requests are going to be traced.
Okay, so the question is, how much sample do you want? And actually, this is a demo, so I sampled everything because I don't want to to send 100 to get 1. And I can show you how I do it. Here, the sampler is, I didn't want to do that. The sampler is always on. But of course, in regular systems, a sample would be good enough because remember, every time you produce data, you need to store it, you need to keep it. So in regular system, probably at the beginning, you would start with a high sample, and once you start to trust your system, you would reduce the amount, which is pretty pragmatic. Yeah?
So my actual question to follow on this, that is, is there any tooling that would potentially allow you to control, like you have multiple instances of an application running, and if you don't want to be sampling all of them equally, maybe you just want to have like a random instance that you just want to actually get sampled. Is that even possible?
So the question is, how do you sample with different sampling on different nodes of the same application? And the answer is very simple. I have no clue. Yeah, I'm very honest. The question is, why would I want to do it? Because, I mean, if Yeah, but in that case, I would want to have a lower sample on every node instead of having different samples for each node, because that's what my approach would be. We can talk about it later, because perhaps you have something in mind that I... Okay. Yeah. Mm-hmm. Yeah. What? Yes. So what you can do actually is here, what I've shown, I have a dedicated config where I have my, sorry, not this one, where I have like a specific header. So probably you can pass your ID in a header or whatever, and then you can say, in this case, I want to sample this, and this case. This will probably depend a lot on your API gateway, but it's possible. Yes. Yeah. It could be super useful, because you would say, hey, if I have this header, I want to start, I want to, let's say, I want to sample more this specific user, because with this specific user, I will use the new version of my system. And so because it's new, I want to have more trust in it, and so I want to sample more. Yeah, it's probably possible. Probably not about user, but about a specific header key or whatever. Other questions? Yeah. I forgot to send chocolate, I'm sorry. You can come afterwards. That's why I told that the first component that is monitored is the most important one, because it's the one that starts the sampling. So if you have 100% on the first component, you will like trace everything. If you have 1%, you will only trace 1% of all the requests. Yep. It's a very good question. So the question is about, hey, what about asynchronous system? What about non-HTTP like business transaction? It's a very good question. I was thinking about adding it to the demo, but then it becomes more complicated. So I didn't try it. So far, everything was that I've shown, synchronous or asynchronous, is HTTP. But about Kafka or other storage, message-based queue, you need to check into the specifics. I believe that I've read, but don't trust me, you need to check, that Kafka has a mechanism to actually, when you send a request to it, it will look at the specific header, it will put it in a metadata somewhere. When you read the message, you can get it back, and so you can get the trace across everything, including the messaging system. Double check, because I have no experience, I didn't make it work, so that's what I read, but I'm not sure. Sorry, again? So the question is about whether there is difference in OpenTelemetry implementation on-prem and on the cloud. Is that correct? You need to check the cloud provider, but I believe if they are saying that they have OpenTelemetry, they are an OpenTelemetry compliant, it won't change a thing, and you could potentially trace a request across multiple cloud providers if they claim they are OpenTelemetry compliant. If it doesn't work, they are not OpenTelemetry compliant, obviously. Okay, let's imagine that right now we have more confidence in OpenTelemetry, but we want more detailed traces. So for example, here I want to have the select. I want to say every time I want, when I do a select, to have the parameter. when I do a select. Or I want to here have this fetch method implement. It was this one, this fetch method implemented. So of course, it's already done here, but by default, it's not instrumented. So I need to go a bit further. And in this case, I need to do manual instrumentation. Manual instrumentation, now you need to involve your developers. You cannot go without involvement of your developers. So the first thing is you actually need now to couple yourself to an open telemetry implementation, depending on your stack. This one is a jar. I have the same for, Python. And here I still do instrumentation, but I will add a couple of annotations. So here, I will create an additional span, specifically, explicitly. Here, I will create an additional span also. And here, I wanted, as I told you, I wanted the product ID. I need to break my code, my nice looking code, I need to break it. Why? Because I need to have this like annotation called span attributes on a specific parameter. And here, before that, I only passed the product. So I need to pass the ID, which already belongs on the product, because here it's a product ID, only to be able to instrument it. Here, if I remove it, it compiles. Likewise, there is no difference. So I need to change my code just to be able to instrument it manually with annotations. There is another way to instrument it. This is like using the API itself. I checked it, it's not fun. So since Spring Boot already understands the annotation, it does everything for me, that's quite easy. And then, as I mentioned, you've got additional data, like here now. Where is my catalog? Here. So I have the fetch and I have the ID here, which exactly correspond to that. This is fetch, this is the ID. On the Python side, no, you didn't want Python. I will answer a question, it's more interesting then. No. And again, that's a very, sorry, I will repeat the question. I'm able to create a span with a local variable. With annotations, no, it's not possible. If you want to do that, you need to use the API. As I mentioned, the API is not fun to use. So in that case, you need to create a dedicated method for that. And then you will add the annotation and it will work. So you will need to break your nicely designed code just to like manually instrument. However, I don't think this level of detail would be necessary in most cases. Yes? The tags can be configured, the attributes, sorry. Yeah, where is it? Here. Tags can be, you mean, okay, I understand your question. You mean like the span attribute here? Okay, yeah. In the end, it will be a tag, but they call it attributes because you can add additional data. As I mentioned, there are some that are like created for you automatically, like the thread ID in case you want it or need it or whatever. If you don't need it, that's not an issue. You will get it anyway, and then you can add additional one, and then they are called attributes. Other questions, perhaps? No, good. Python, or I finish the presentation with a couple of slides? No Python, that's fine. And that was it. So thanks for your attention. As like a takeaway, in distributed systems, observing your system like in a dynamic way is not an option, it's mandatory. If you are a developer, you want to help your ops colleague. If you are a DevOps on ops, you will be the one who will get pressure if something doesn't work. So you absolutely want to have something observable. If your stack, and everybody seems to be loving Java and the JVM, then start with auto-instrumentation. It's not hard to do, and it gets already tons of benefits to have insight into your system. If you want to get further refinements after you are comfortable with the raw data, with like auto-instrumentation, then you can do manual instrumentation if you are using Spring annotations. If you are using another framework that is not so like OpenTelemetry compatible, you can directly call the API itself. You can follow me on Twitter, you can follow me in Mastodon. If you are interested about the demo, you can check it. So everything is on GitHub. And if you have interest in Apache API 6, I encourage you to have a look at it. Thanks a lot for your attention. And everybody who asked questions and the others, I have some nice Swiss chocolate. Thanks a lot.